Please check the solutions for your previous assignment. First main, fill in the blanks to make each of the following a true statement and specify the property. Question number 1, 458 plus 639 equals to 639 plus 458. It is commutative property of addition. Question number 2, 8063 plus 0 equals to 8063. So, it is additive property of 0. Next, 53,501 plus 574 plus 799. So, last two has been grouped here. So, now 574 is out of the bracket and inside the bracket it is 53,501 plus in the dash it will be 799. So, it is the grouping property, is it? So, it is associative property of addition. I hope all of you have done correct. Next main, question number 1, find the sum. I hope you have done the addition and finally you got the sum as 5633. Yes. In the second part, also find the sum. The grouping has been changed here. So, if you do the addition here, you will get the sum as 5633. I hope everybody has done. Third question was there, are the two sums equal? So, as the value 5633 in both the cases, so you have to write yes, both the sums are equal. Now, question number 4, state the property satisfied. Which property has been used here? So, it is nothing but associative property of addition. Third main, which of the following statements are true and which are false? Question number 1, 0 is the smallest natural number. It is false. 400 is the predecessor of 399. It is false. The whole number 0 has no predecessor. It is true. 600 is the successor of 599. True. The predecessor of a two-digit number is never a single-digit number. It is false. I want to explain it here. Take one example of a two-digit number as 10. So, the predecessor 10 minus 1 will be 9. So, the statement here is not working correct. Okay. Next, all natural numbers are whole numbers. Yes, it is true. The successor of a three-digit number is always a two-digit number. It is false. Fourth main, find the sum by suitable arrangement. Question number 1, 1983 plus 647 plus 217 plus 353. So, while doing the grouping, you please be careful. So, here 1983 can be grouped with 647 or can be grouped with 217, because I told you to check the units place to get as tens. Okay. So, there are two possibilities. So, choose the best one. I have grouped 1983 plus 217. Why? You can check the next step and get the answer. And 647 and 353 in other group. So, after the addition, you can check the first group is giving the sum as 2200 and the second group is giving the sum as 1000. If you do the final addition, you will get 3200. If you want to do in some other way grouping, you try and then check which is the best one. Second sum, it is very easy. So, 1 will be grouped with 99, 2 will be grouped with 98, 3 will be grouped with 97, 4 will be grouped with 96. So, if you add these pairs, so it will give 100 plus 100 plus 100 plus 100. So, final sum is 400. In our last class, we have discussed about the properties of whole numbers with respect to addition. So, let us have a quick recap of those properties. So, first property we discussed, closure property. Can you remember? This property says sum of two or more whole numbers is also a whole number. We have chosen a and b as two whole numbers. The sum a plus b, we proved that is also a whole number. Second property, commutative property. This property says if the order of the whole numbers is altered, their sum remains unaltered. And the general form we wrote as a plus b equals to b plus a, where a and b are any whole number. Third property, additive property of 0. This property says the sum of 0 and any whole number is the same whole number. We wrote the general form as a plus 0 equals to 0 plus a equals to a, where a is any whole number. Yes? Fourth property we discussed, associative property. According to this property, change in grouping of whole numbers doesn't change their sum. And the general form we wrote as a plus b plus c equals to a plus b plus c, where a, b and c are any whole numbers. Today we will discuss the properties of whole numbers with respect to multiplication. Let's have a quick discussion on multiplication of whole numbers. Look at this example. I am adding 6 here. How many times I have taken? 1, 2, 3, 4, 5. So 6 plus 6 plus 6 plus 6 plus 6. And the sum is here 30. So I am adding 6 in a repeated way. How many times? 5 times. So 6 has taken 5 times. Yes? Can I express it like this? 6 has been taken 5 times. So 6 into 5. If you go for the table of 6, you will get 6 5s are 30. Yes? So we can tell that multiplication is nothing but repeated addition. You know. So here 6 into 5 equals to 30. So it is the process of multiplication of whole numbers, as 6 and 5 both are whole numbers. And the symbol of multiplication is denoted by this cross sign. Okay. Now this 6, 5 and 30, they have a specific name because we are using the process as multiplication. So the number to be multiplied is called multiplicand. The number to be multiplied means here it is 6. So 6 is called as multiplicand. And the number by which we multiply is called as multiplier. So here we are multiplying by 5. So 6 will be called as multiplier. And the result of the multiplication, that is 30. The result we got as 30. So the result of multiplication is called the product. Yes? So here 6 is multiplicand, 5 is multiplier and 30 is product. Yes? Let's move on to the properties of whole number with respect to multiplication. So look at the examples here. Here I have taken one whole number 9. I want to multiply this whole number with another whole number 8. Okay. So 9 8s are how much? 72. So I am repeating one more time. I have taken one whole number 9 and multiplied with another whole number 8. Now I want to ask you the product. Is it a whole number? Yes or no? Yes, 72 is also a whole number. Now I want to take one more example. I have taken 10 multiplied with 7, again multiplied with one more whole number 3. Let's check the product here. It is 210. So 10 is a whole number, 7 is also a whole number, 3 is also a whole number. So we have taken 3 whole numbers and multiplied. And the product, what we are getting, 210, is it a whole number? What do you think? Yes, it's also a whole number. So from these two examples, what we can say, what we can conclude? Can anyone try? Just think. So we can say that product of two or more whole numbers is also a whole number. What I told? Product of two or more whole numbers is also a whole number. We discussed right now that product of two or more whole numbers is also a whole number. This property of whole numbers with respect to multiplication is known as closure property. Okay. So now we will express this closure property in general form. So let's take A and B as two whole numbers. So their product, how much it will be? A into B. Yes. So if A and B are two whole numbers, then their product A into B will also be a whole number. So look at this statement. If A and B are whole numbers, then A into B is also a whole number. I hope you are clear. Look at the example here. I have taken two random whole numbers as 7 and 5. I want to multiply them. So 7 into 5 gives me the product as 35. Now I have interchanged their place. So 5 into 7 is giving the product as the same 35. Can you tell me now 7 into 5 is equals to 5 into 7? Can you say that? Can you guess which property I am going to discuss right now? As you have already learned properties of addition. So I asked you the question, is 7 into 5 equals to 5 into 7? What do you say? Look at the product part. Here, when it is 7 into 5, the product is 35. When it is 5 into 7, that product is also 35. So if we look at the product, we will be able to answer. So yes, they are equal. So here we have interchanged the place of 7 and 5, but the product didn't change. Okay. So let's take one more example. Look at the example here, what I have taken. I have taken 12, a whole number, one more whole number as 10, multiplied them and got the product as 120. Now I will interchange them and you can see 10 into 12 also gives you the product as 120. So can you tell me that is 12 into 10 is equals to 10 into 12? If you look at the product, you will be able to say the answer. Yes, they are equal. So in the previous example, I asked you one question. Can you say what the property I am going to discuss? Can you guess it? I hope you can. So let me clear the property first. That we have interchanged the place of the whole number, but the product didn't change. So we can conclude that change in order of whole numbers doesn't alter their product. What I told? Change in order of whole numbers doesn't alter their product. So this property is known as commutative property of whole numbers with respect to multiplication. I hope you have understood. As we have discussed about commutative property, now we will express this property in general form. So, let's take A and B as two whole numbers. So, if we multiply A and B, the product what we will get, and if we interchange their place, the product will be as B into A. They will be equal. So, look at the statement here. If A and B are any two whole numbers, then A into B equals to B into A. A and B are any two whole numbers. So, if I multiply, the product will be A into B, and if we interchange their place, then the product will be B into A, but they will be equal, means their value will be equal. I hope you have understood. Now, I want to explain commutative property on number line. In your previous class, I have explained commutative property for addition. Right now, in this class, I have explained commutative property for multiplication. So, can you remember what we have explained commutative property for addition? I hope you all know. So, I am just reminding you. If the order of the whole numbers is altered, their sum remains unaltered. Yes? In the general form, we wrote as A plus B equals to B plus A, where A and B are two whole numbers. Yes? So, now I want to explain commutative property for addition first. Okay? So, look at this example here. I have taken two whole numbers 4 and 3. I want to add them using a number line. So, if we want to add using the number line, what we have to do? From 0 we have to start counting. First the whole number is 4. So, from 0 we have to take 4 steps. So, 0 to 1, 1 to 2, 2 to 3, 3 to 4. So, again we have to plus 3. So, from 4 we have to go for another 3 steps, and we have to find out how much we are getting. Okay? So, let us start. So, from 0 to I have to reach till 4 first. So, I have reached 4. Yes? After 4, what we have to do? We have to go for another 3 steps. So, from 4 if I go, so 4 to 5, 5 to 6, 6 to 7. So, I am reaching at 7. So, 4 plus 3 on the number line, it is showing that you are landing on 7. Yes? So, 4 plus 3 means 7. We can understand. Now, we will do the same addition, but the order has been changed here. So, it is now 3 plus 4. So, we will do the same addition on the number line. What to do? We will count 3 steps from 0, and then we have to count 4 steps from 3 and find out what the sum is. So, let us do it. So, from 0 take 3 steps. I have reached 3. Yes. Now, I am counting 4 steps. So, from 3, 3 to 4, 4 to 5, 5 to 6, then 6 to 7. Yes. So, you have landed on 7 here. So, can you remember now, in the previous number line, we have showed the sum for 4 plus 3. Now in this number line we have showed the sum for 3 plus 4. So 4 plus 3, the sum we got as 7, and now 3 plus 4 also the sum 7. So therefore what we can say? Therefore we can say that 4 plus 3 equals to 3 plus 4. So for addition we proved through number line that commutative property is holding good. You will not get any pair of whole numbers for which the sum is different when the order of the addition is changed. So you can add two whole numbers in any order. So we can say that addition is commutative for whole numbers. Now I want to explain commutative property for multiplication through number line. So look at the example here. I have taken two whole numbers as 2 and 3. We have to multiply. So 2 into 3 means what? We know multiplication is repeated addition. So 2 has been added 3 times. Yes? So we can follow this addition method and we will do it on the number line. Let's draw a number line here. Now we have to take 2 3 times. So take 2 first. So I have taken. Next another 2 steps. Next one more 2 steps. So I have taken 2 3 times and we have reached where it is 6. So the final result is 6. Through number line we can see 2 into 3 is 6. Yes. Now we have changed the order. So it has become 3 into 2. So we will find out this product on the number line. So draw the number line. So 3 has been taken here 2 times. Yes. So first we will take 3 steps, then we will take another 3 steps. Yes. So from 0 I will come first 3. So I have to take 3 2 times. So one more. So I have reached here 6, you can see. So the final answer is here also 6. Though we have changed the order, but the final product is same for both the cases. Yes. So we can tell that therefore 2 into 3 equals to 3 into 2. So you can multiply two whole numbers in any order. So multiplication is also commutative for whole numbers. Let's move on to a new property. Look at the example here. Here 9 has been multiplied with 0. So 9 is a whole number multiplied with 0. Now I have interchanged their place. So it is 0 into 9. In both the cases the product will be as 0. Take one more example. Instead of 9 I have taken one more whole number as 37 and multiplied with 0. Here also I have interchanged their place. So 0 has been multiplied with 37 and both the cases you are getting the product as 0. Let's take one more example. It is 2385 multiplied with 0. Again I have interchanged their place. Again I am getting the product in both the cases as 0. So after looking at these 3 examples, what you can say? You can say the product of 0 and any whole number is 0. Is it clear? The product of 0 and any whole number is 0. This property is known as multiplicative property of 0. Yes. Now we will express this multiplicative property of 0 in general form. So let's take a as any whole number. So look at the statement here. For any whole number a into 0 means a has been multiplied with 0 is equals to 0 into a. If you interchange the place, gives you the product as 0. Means a into 0 gives you 0, 0 into a also gives you 0. So this is the general form of multiplicative property of 0. Look at the examples here. Example number 1. I have taken a whole number 8 and I have multiplied with 1. So 8 ones are, the product is 8. So if I interchange the place, so it becomes 1 into 8. Again the product is 8. Here I have taken one more whole number as 76 and multiplied with 1. So 76 ones are 76. I have interchanged their place, so 1 into 76, again the product is coming 76. In the third example, I have taken one more whole number 5912 and multiplied with 1. The product is coming 5912. If I interchange their place, again the product is coming 5912. So what we can conclude seeing these three examples? So we can say that the product of 1 and any whole number is the same whole number. The product of 1 and any whole number. So we have taken 8, 76, 5912. But we have multiplied with 1 and the product is coming back the same whole number. Yes. And this property is known as multiplicative property of 1. Let's express this multiplicative property of 1 in general form. So take a as any whole number. So how to express? A into 1 means any whole number a has been multiplied with 1. So the product will be a, the same whole number. If you interchange the place, means 1 into a, again the product will be a, the same whole number. Okay. So for any whole number, if you multiply with 1, it gives you back the same whole number as product. Observe the diagram here. So there are 4 boxes. Look at the first box. Here I have drawn some red big dots looking like bindi. So here just count how many red dots are there. You can see 2 dots in 3 rows. Yes. So how many are there total? 2 into 3 in the first box. Go for the second one, third one and the fourth one. You can observe, you can find out that it is same in each box. Yes. I told you have to find out the total number of dots. So first find out each box, then you will go for total. So each box, how many are there? It is 2 into 3 because I told you 2 dots in 3 rows. So 2 into 3 means 6 dots are there for each. There are 4 boxes. So how many will be the total? If I multiply this number with 4, you will get the total number of dots here. So total, how much it will be? So 2 into 3 multiplied by 4. So 2 into 3 gives you 6. If you multiply by 4, it will give you the product as 24. Okay. Observe this diagram now. There are 2 boxes. Come to the first box. You can see there are dots and there are 3 dots in one row. If you count, you can see there are 4 rows. So what will be the total number of dots here? So 3 into 4. Yes, in one box. Go for the next box and check it. Here also you can see 3 dots in one row and there are 4 rows. So same it is here also. So we will find out the total number of dots here also. So let's first we will find out for each box. So each box it is 3 into 4. So it gives you 12. Now find out the total. How many boxes are there? 2 boxes. Okay. So total will be how much? 3 into 4 multiplied by 2. So 3 into 4 gives you 12. 12 into 2 gives you 24. Now compare the previous diagram and this diagram. You can see the number of dots are same. The final or the total number of dots are same, but the arrangements are not same. Though we have arranged them in a different way, but as we have counted the total number of dots, that we are getting same. Okay. So can you say that 2 into 3 into 4 is equals to 3 into 4 into 2? What do you feel? As the product is same in both the cases, so they are equal. So we can write that 2 into 3 into 4 for the first diagram is equals to 3 into 4 into 2 for the second diagram. What we have discussed right now, let's check with one more example. Here I have taken 3 whole numbers as 7, 6 and 10. I want to group them in different way and find out their product. And finally I will compare the product whether they are coming same or not. So here I have taken 7 and 6 together in a group and then multiplied by 10. So 7 6 gives you 42. 42 into 10 gives you 420. Now look at here. I have taken 6 and 10 together. So 7 into 6 into 10. So 6 into 10 gives you 60 multiplied by 7. 7 6 are 42. Again it is 420. Yes. So what we can say here? Though we have grouped them in different way and found the product, but the final product is same. Therefore we can write that 7 into 6 into 10 means this first method is equals to 7 into 6 into 10, the second one. So what we can conclude from here? We can conclude that change in grouping of whole numbers doesn't alter their product. I am repeating one more time. Change in grouping of whole numbers doesn't alter their product. We have changed the grouping. Here 7 to 6, here 6 into 10. But ultimately the final product in both the cases are same. So this property of multiplication is known as associative property. What I told? This is associative property for multiplication. Now we will express this associative property in general form. So let us consider A, B and C as any 3 whole number. Okay. So how to express them? Look at the statement here. If A, B, C are any whole numbers, then A into B into C equals to A into B into C. So we have grouped A and B together, multiplied, and that product has been multiplied with C. Here B and C has been grouped together and multiplied, and that product has been multiplied with A. Both the product, the final product will be the same. and this property I told is known as associative property for multiplication. Now you tell me that why should we do this kind of grouping? I have explained in the property for addition also. Can you remember? We do this kind of grouping to make our calculation easier. Yes? So please note down this point, that while multiplying 3 or more numbers, group them in such a way that the calculation becomes easier. So we have to arrange them suitably, then we will multiply. So we will work out few sums and it will be much more clear to you. Find the product by suitable rearrangement. Look at the sum. 2 into 1768 multiplied by 50. You all know multiplication. So you can do, I know, step by step. First you will multiply 2 and 1768. Whatever the product will be there, you will multiply with 50 and you will get the final product. But now we have learned associative property of multiplication. So we will rearrange and then we will multiply. So I have grouped here 2 and 50 and I kept 1768 separately. So it is the application of associative property of multiplication. Look at the next step. So 1768 as it is, 2 into 50 gives you 100. Yes? Find out the final product. So 1768 along with 20. So it is very easy. That's why we are using associative property of multiplication, and that is the rearrangement for multiplication here. We'll do few more sums. Look at the next sum. 285 multiplied by 5 multiplied by 60. So you have to find the product by suitable rearrangement. Work out with me. The first thing you have to do to group them. So how to group them? You have to check, you have to find out which will be the easier one. To find out the answer, that group only we will do. Look at here what I have done. I have taken 5 and 60 together in a group and I kept 285 separately. You can say, can we take as 285 and 60 together? I will tell yes. You please try that way also and then compare which is the best grouping. So it is associative property of multiplication as I have done the group. Now finish up the product. So 5 into 60, 5 into 60 gives you 300. So 285 into 300. Multiply 285 into 3 along with 2 zeros. So it is 85,500. I hope you are clear. Look at the sum here. 125 into 40 into 8 into 25. So we have to find out the product by suitable rearrangement. So how to rearrange them? When we are rearranging them, we are trying to bring them in tens, hundred and thousand like this, so that our multiplication will be more easier. So look at here what I have done. I have taken 125 and 8 in one group, 40 and 25 in other group. But I want to tell you, you can do other grouping, other possible grouping also. Means 125 and 40 together, 8 into 25 together. So please do that way also. Now you try to work out with me. Always mention the property wherever you are using. Always you mention. Now we will do the multiplication part. Means 125 multiplied by 8. How much it is? So it is nothing but 1000. Again 40 into 25. 4 25 is 100 along with zeros. It is also 1000. Now the final product. How much it will be? 1 along with 6 zeros. So it is 10 lakh. Is it? So the other way, I mean you group in other way and find out the answer. Try to check which is much more easier and follow that one. I hope all of you are clear with this kind of sums. Look at the assignment. First men, state the property used in each of the following statements. You will observe and find out and then write the name of the property. Second men, find the product by suitable rearrangement. There are 4 sums. I know you all can do. So please try these sums. I'll check in my next class. Thank you.